Welcome back everyone, my name is Pedram and this is where we do advanced time series analysis, deep forecasting. Alright, so let's wrap up the profit section of our module number 8. We started with the theory. We talked about the pros and cons of profit and why we should go beyond that in the theory lecture. And then we reviewed the paper together and we looked at all the details you need to know. And we needed to do that because next time when we do NeuralProphet, it's just an extension of the profit. And then we jumped into the Python part. Let me actually show it to you. So this is what we did last time. So we did the basic version of the Facebook Profit Notebook in Python. And now this time we're looking at the more challenging Kaggle competition, doing the advanced version of Facebook Profit for business time series. Actually, we're going to do the multivariate version. So let me show you where you can find the materials. Go to the deep forecasting on my GitHub, lectures and code, and then module 8. This is what we covered last time, and this is what we're going to do today. So module 8, profit advanced. And in the video, you will see that it's module 9, so just don't worry about it. That's where I decided to just take out the transformer section of the course that I previously developed. And by the time that we get a stable and working transformer model, I'm going to add it back to the course. All right, so let's jump into that one.
Today, we're going to do multivariate time series forecasting, right? And as soon as you hear the term multivariate time series forecasting, we have to be careful. In the Facebook Profit, there is this database data frame that you have to construct. It's called futures. Inside that futures, you have to provide the value of your accelerated variables into the future. If you want to predict 24 months from now, you have to provide that value for 24 months from now for those extra variables, right? So this is something that we have to incorporate into the futures data set. So let's see. Historically, our futures data set was just one column, and that column are the dates, both in sample and out of sample. And out of sample simply means how many time steps you want to forecast into the future. So we are going to talk about that one. So obviously we cannot apply to, any kind of multivariable forecasting because, we talked about it. Imagine you're trying to predict this stock price and you want to take into account the CPI, inflation, basically the same thing. GDP growth or oil price, gold price, all these things, it is impossible because you cannot predict them into the future, let alone you want to use them to predict something else into the future, right? But this is different. This is time series business, and in time series business, there are some variables that we can perfectly predict into the futures, mainly holidays, right? So we can have a sense that our holidays are going to impact our variable. All right. So this is quick reminder. The data set that we're going to work with is coming from a Kaggle competition. This is this drugstore called Rossmann. And this is a drugstore chain in Europe. They have more than 1,100 stores. And literally, you want to make prediction for every single store. So that's ideally, you want to create a pipeline and use that pipeline to make a prediction for 1,100 stores. You can easily extend this idea to Walmart product, Amazon product. So this is very, very applicable. Okay. So that's why I picked this data set for us to work with. If you understand this one, you can easily extend it to any kind of retail store at retail business for different stores, right? Hey. Okay. So let's go back. So that was let's see, this is a data card competition. I think there's another link that I put there that talks a little bit more about that competition is this one. Yeah. There you go. So the competition is closed now, but the task is to predict 6 weeks of daily sales in advance, right? Again, for 1,100 stores. So this is, obviously you should not do it separately. You have to create one pipeline and then just repeat that pipeline for 1,100 stores. So this is very common practice we do for time series prediction. We did something like this for an AC project. We had 32,000 separate time series, and so obviously we pick 5 of them as samples, we train models on them, and then once you are confident with the model, we put it in a for loop and then you run it as a pipeline. But obviously it's going to take up for a while. And if you do it, for example, if I'm going to do 11, so guys, this is important. This is why this Facebook Prophet is useful in practice, right? Because of that fast processing. If I were to do 1100 predictions using ARIMA, using auto ARIMA, it's going to take forever. It really is going to take forever. Unless you have, super huge compute power, you can do parallel processing, because some of them, these are recursive models. ARIMA is a recursive model. LSTM, RNN is a recursive model. Honestly, it really doesn't matter if you're running about CPU or GPU, because these are sequential models. You cannot parallelize it in that sense, right? So that means that you're running on a CPU. So now parallelization is not for the modeling part, it's just for the application. Let's run it on 100 different CPUs, and then on each CPU run for 10 of them. So you get 1100. Okay, something like that. Okay. But the model itself is not parallelizable if you want to do ARIMA. But Facebook Prophet, nah, it talks about it, right? So this is not a sequential approach. It has this non-recursive nature. So within the model, you can do some parallelization, which comes handy. So that was the whole motivation of Facebook Prophet in business, because typically this is not abnormal. So we see something like this all the time. Okay. So again, Amazon, thousands of products. Walmart, thousands of different products. Not only thousands of different products, thousands of different stores. So we have to make a prediction for every single of them. Okay. So that's why scalability of the models matter, and then that's why Facebook Prophet was a huge step forward. Okay. So here's a paper, here's a documentation. We can have the documentation open as well, because I'm going to refer to it probably. Okay. And today we're going to focus on that holiday columns and forecasting into the future using multivariate, right? All right. So again, surprisingly, Rocket was already built in Google Colab. It wasn't a thing, even last year, I think. So this is new. We're incorporating it into Google Colab. Here's the data frame. So right now, we're going to see, these are the columns, and we're going to see store numbers. Obviously, we're going to filter for one of them, create a pipeline for one store, and apply that pipeline for other stores, right? So what do we have? Days of the week, dates, sales. If you have days of the week or month of the year, honestly, this is just extra information. You don't need it, because as long as you have a dates column, you can extract all of those things. So this is just extra. I'm gonna remove it or don't use it. So we have sales and customers. These are interesting variables. Sales, this is our target variable. Customers, we're not going to use it. Well, we can, but because we cannot forecast it into the future with certainty, we say let's not use it. But we can. I'll show you how to do that. You can try it at home and see if it's worth it. This is if the store is open or not. So we're gonna look at the data set, decide we want to just model the days that the stores are open, because if the store is closed, sale is going to be 0, we can safely get rid of them. You cannot do the same thing with every month. So with Prophet, we know that if you drop them, the time index doesn't matter. It can handle the irregular time series. So we can do our Prophet. So again, these are advantages of Prophet. So we can have it. It's not impossible with ARIMA, but you have to extrapolate things, right? And if you have a bunch of zeros in sales, it's going to give your model harder time to predict them, right? So I'm going to explain it in very details, and we're going to visualize this store sales over time. And promotion, if the store is offering promotion or not, obviously it has something to do with sales, right? And state holiday, school holiday. So this should be off the slide. These are public holidays. By the way, this is a data from Germany. So we're going to use this state holiday as their calendar. I'm going to go ahead and add Germany calendar as well, because Facebook Prophet allow us to do that. But you're going to see it's nothing different from state holiday. So we can either use this one or use the public holiday for Germany. But this one, we have to, I need to borrow this column because the school holiday, I don't know, at least there's no Python package that talks about school holidays in German. Okay, so we're gonna leverage this one. School holiday. Okay, so hopefully the variables are clear. We're gonna go ahead and look at the information. This is the entire data set, right? So it's 1,017,209 entries. And I'm gonna go ahead, look at the basically value counts for stores. And it seems that this is pretty balanced for all the stores, right? We have 1,115 stores, so 942 days of information. So this is what we have, 942 days. Yeah. Okay, so we're gonna pick one of them. Let's say, for example, store one, do some visualization and try to make a model on that. After that, once you're happy, we can put it all in one function, call it my store predictor or forecaster. And then you have a function, depending on how you want to define what you want to output. But then you can call that function, put it in the for loop, and put it for all the 1,100 stores. Okay, so that's the pipeline approach. All right, so I'm gonna go ahead and create a new data frame, call it store one, simply because I'm filtering store one, and I wanna just for visualization, for now, we're going to revert to back, right? For now, I'm going to set the index is equal to date, because with this, I can visualize time series better, right? But we know that Facebook Prophet doesn't like things this way. It wants you to specify two columns DS. So yeah, I have to pre-index these things from days to columns, column DS, like sales are going to be Y. And then we're going to add a bunch of these things as extra regressors. Okay. And yeah. Okay. So a little bit of visualization. Let's plot these sales. So this is the sales for store one. And if you just pay attention to that, obviously these zeros, you know, going to make the model job a little harder, right? Because it's trying to predict something, those zeros, those zeros, those zeros. So hopefully the model now is going to pick it up if it is pretty regular in this case, which it is. You know, we're talking about Sundays, and Sundays the stores are closed, and maybe some other days in the holidays that the store. So those holiday ones are not. So let's say you want to do this with A, right? If it was only Sundays that the store was closed, I really can do a perfect job. But because it's also has some holidays, I really cannot have. Does that make sense? Yeah. So you see, okay, these are, but the stores are closed. And then if I remove them, how do time series look like, right? So let's go ahead and remove them. Because again, guys, if you knew nothing about profit, you cannot simply go ahead and model for all the open rates. But because I have profit model, I can say, you know what? Let's get rid of close days. Look at the data set, make a prediction, and I'm not worried about these missing information. I'm not inferring any information for those missing values. Does that make sense? Because Facebook Prophet, it's a non-recursive model. It can handle irregular functions. Okay, cool. For many cases, we don't need that, right? So for many cases, for example, I don't know, you have a time series, it's monthly, and then you cannot care less about it. If you have a daily data set, so that's why you should not totally rely on Facebook Prophet as well, because most of the time, you know, the frequency, especially you're working for Federal Reserve, and then the frequency of the data by no means is daily. And at a more macro level, we cannot care less about daily holidays. So if you're modeling, you're doing monthly or quarterly, honestly, these things doesn't matter. If you do a remodel, Facebook Prophet. But for business data set, which we explored the properties last time, holidays is a big deal, especially for sales, demand forecasting, things like that. Okay. All right. So, and here's the version without the holidays. So this looks a lot more, it's convenience for modeling perspective, right? So if I have something like this, yeah, is it stationary? Probably not quite, but again, the average is constant, the variance is going up and down, I get it. Maybe the correlation is changing over time. So it's, if I run a stationary test, probably it's going to become barely stationary. But the point is that this forecasting this thing is a lot easier than this, especially if the holidays are irregular. Okay, so we are going to work with this list. Okay, these are the columns. Again, the preparing the data for profit. So I'm going to go ahead and say, so this is what we do. Remember, I changed it to index. So I'm going to sort the index from day one to, because the data comes in reverse. So this is the original data. 31st of July and then 30th. And then, so this is achronological. We want to make it chronological. So that's why we just store the index. By the way, the Prophet can handle it. I didn't need to do this, but just visually we are more familiar to go from day one to day, but whatever. I see. I'm going to reverse this index. Right? So I'm going to say sort index. Again, this is another reason that we did. We changed that from column to index because we can do this sort of operations, right? Like a sort index, and then the name the index is sort. I'm going to reset it. I'm going to say reset index. I will need two new columns, dates and sales. So these are my date and sales. Where is it? Date and sales. Rename dates to DS simply because Prophet wants it that way, and rename sales to Y. This is what we're doing. Okay. All right. Now, if you look at the head of this Prophet data set, is this. Okay. So again, it's sorted chronologically as well, from the 2nd of January 2013 all the way to 31st of July 2015. It's sort of like, yeah. Okay. Any questions so far? It should be pretty weird, straightforward. Okay. Now, for now, the only review, so the Prophet can handle missing data. So we talked about this, right? So we don't need to interpolate values for store close dates. So remember, guys, we're working with only when the store is open. So you're working with this data set. Store open only when the store is open. Okay. All right, so that's why this is our open days. The tail, we talked about it. Let's create a base model. So this is, we did something like this last time. We're going to create 3 models: base model, and then advanced model, and then hypercrowded or tuned model, right? So the tuning one is new. So we hadn't talked about it last time. But this is a very base model. I didn't touch seasonality. I didn't touch holidays, nothing. No extra regressors, nothing, right? So right out of the bat, this is how Prophet is going to perform. But remember, guys, you train the model, and then you have to make forecasts. For making forecasts, you have to create that data frame called futures. So if I want to treat it as univariate time series, that feature, simply I can say make futures data frame, and then how many days? I want to make prediction for 1 year, 365 days. Okay. All right. Okay. And by the way, this is basic Prophet thing. No, okay, when you do create this called 365, it's going to create forecast for every single day in the calendar. Either it is holiday, it's not holiday, whatever, business day, non-business day. It's just going to go from day 1 to day 365. So if you're doing forecasts with Prophet or stock price, just be aware. It's going to make some predictions for Sundays or, I don't know, close, or when the market is closed as well. Those are just simple interpolation. What was the price Friday? What was the price Monday? Do a simple linear interpolation. Just be aware. This is one of the caveats of basic Prophet. If you're doing stock price prediction, it makes no sense for those days, right? And it's gonna impact your error rate as well. Are you following here? Okay. All right. So in this exercise, in this simple benchmark, which we call it baseline, yeah, base model. Remember, it's univariate. So this is my future. I didn't need to add any extra variables here because that's the only thing I need is time. So go ahead and make prediction from day 1 to, if I show you the head of it or tail of it, well, actually, let's do tail. Remember, our data goes to July 31st. 2015. This is July 30th, 2016, 365 days. Both in sample and out of sample. All right, so let's go ahead and make prediction. Remember, our base model was M1, predict features, and we have seen this before. And not all the columns we need, well, obviously we can interpret them, but the ones that we need are time, while hat, and lower and upper bound, right? So this is basically, these are the prediction I can plot it out. Oh, by the way, you don't need to stick to Facebook profit visualizations. You have a simple data frame here. You can do whatever. You can use Matplotlib or Seaborn if you're more comfortable working with that, or if you want to jump, make some customization for your plots, right? Here they're going to use Facebook profit, but again, we can perfectly apply that thing to your forecast data frame. Yeah. I think I talked about this naming as well last time, that forecast, this is what the documentation used. But remember, this is not just forecast into the future. These are in-sample predictions as well. So if I look at the head of it, it's going to go from day one. Tail is go all the way to day 365 into the future, which is this. Okay. All right, then we can plot. These are basically, obviously, the actuals are from 2012 or 13, yeah, 13 to 15. And then these are the blackouts are the actuals. And here, this is the 365 page. And it is going to make some predictions for the times that the store is closed. Just keep that in mind, which is just an interpolation. All right. So the confidence interval, again, depending on, I don't know, the average is 4,000 or 4,500-ish, I assume. And the intervals are not narrowed. We're talking about 1,000, right? So, but again, it is what it is. This is what the model is predicting, producing. I can look at the components plots. Again, this is a baseline. And as you can see, as we go further into the future, let's say 365-ish, the model will start having hard time, right? Start having hard time. That's why the intervals is increasing. But for weekly and yearly seasonality, so this is what we get. And again, this is just fake. Just be aware how to interpret Facebook profit. Sundays, the Sundays are closed, right? Do not read too much into this thing. This is just a simple interpolation that model is doing between Saturday and Monday. So basically, the battle. This is your Saturday. That's your Monday. Isn't where this Sunday is. Right. So this is I don't read too much into that. You have to know the nature of your data set, right? And then the rest of it maybe makes sense, right? Friday. This is typical for my household. Saturdays we go to the store more. Well, Fridays, Dara always gets sick over the weekends. This works in my, I know, I'll take this one. Mondays, yeah, probably, yeah, because doctors are closed and drugstores are closed. You rush into drugstores. So it seems that it makes sense, right? Are you following? Again, it should at least, it should make sense to, if you don't see the right seasonality, say, okay, maybe I didn't need to have weekly seasonality. By the way, you can turn it off. In the Profit open close parenthesis, weekly seasonality is equal to false. Okay, if you want to switch that off or on. And again, by default, it knows that your data set is daily. It doesn't make any sense to create daily seasonality, right? If you want to create daily seasonality, then you have to have more granular data, maybe hourly data. All right, but by default, it's false. Okay, and annually sales is picking up over December. I don't know if it makes sense or not, but it seems that it's cyclical, but the magnitude is not as small. Honestly, it's 500-ish, or maybe 100, 200 here. I don't know how to interpret that. I'm not an expert when it comes to drugstore sales or medical stuff, but it seems that, yeah, this is your winter, right? November. Well, that makes a little sense. November, December, January. Yeah, depending on Germany. Is Germany cold depending on the weather there, right? But is Germany cold in February? Probably the data says that probably not. You're done with the flu season, etc. Okay, this is how we should read the data. Okay. All right, so now let's get into our custom model. And this is very customized because we want to do multivariate time series forecasting, okay? So we talked about these things. We can play around with the change points. We can play around with the seasonalities. Remember those variables, tau, and then beta, and then sigma and gamma for holidays. So we can play around with all those things. But before getting into the modeling, the most important thing, guys, remember, the most important thing, especially if you're doing multivariate time series forecasting properly, is creating your futures data set. Creating your futures data set is the most important one. Because when you train a model, when you're training a model, you don't need that futures data set. But when you want to predict, the model is reading that futures data set to make a prediction of the future. So let's create that one. All right, so just remember, this is the head of the data set, store one open, and okay. So I want to explore a little bit about this state holiday and school holiday. So let's look at the unique values of state holidays, and then let's start with that, and then you're gonna get into school holidays. So I'm gonna show it both for, guys, remember, this is store one is the entire data set for store one. Store open is only the open days. So if I look at the unique values for state holidays, you see the two. We'll see if they're different. It seems that here they are. And I check the documentation. These letters stand for something, right? These are strings, right? So 0 means no holiday. A means public holiday. B means Easter. C means Christmas. Okay. So I have public holiday, Easter, and Christmas, right? So there is this, if you remember from last class, there's this holiday Python package that preprocessing is using. If I add that as an extra regressive to the model, and if I apply German holidays to my store one open, I should not see any effect. Is everybody following? Because look at this one, so open, there's no holiday there. So if this is my sanity check, right? We're going to do that and see if that statement holds or not. I'm going to apply, because remember, we said that you want to work with only open days because it's easier to model that. You can go ahead and repeat this entire process with just store one instead of store one underscore open. It's simply just changing one word, right? And you'll see how it performs. But here, for me as a modeler, as an analyst, I have this sanity check. I'm seeing that store one open should not have any holiday impact. So I'm going to add that holiday impact to my model. It shouldn't capture anything. Does that make sense? Because if there's no holiday in your data, adding that holiday regressor should not be explanatory. Okay? So let's do that. So that's one thing. Just remember that. That's about the state holiday. The other one is the school holiday. So I don't have something like that in preprocessing to check it. So I would say, you know what? I will add it manually as a regressor to the model. All right. So this is the way that again, guys, there are many different ways. This is the way that I decided to work with this model, right? You could say, you know what? I'm going to work with the state holiday as a separate vector added to the model and see how it works. But I would say we already have that holidays from preprocessing. I'm going to use that one, right? And the reason that I'm hesitant here is that this is going to be a little manual work, right? What if you want to predict, I don't know, 4 years into the future, 3 years into the future? You have to manually add those holidays for 3 years. What if your train sets was 20 years? You have to manually add things for 20 years. And so to avoid that, I'm trying to use automation as much as possible. So I'm going to use preprocessing holiday calendar. And here, in order to make sure that it's working properly, it should not have any impact on my open days. For, as I said, for school holidays, because I don't have any Python packages for Germany school holidays, I'm going to rely on this variable and say, you know what, I'm going to use it. And beside that, we'll see there, if I look at the unique values for school holidays in all the data and all the open days, It's either open or not, right? So here for school holiday, it seems that we do need to manually add them as a dummy variable, new regressor to our profit dataset. Is everybody following? Okay, so again, this is the way that I treat it. You could perfectly add the state holiday as an extra regressor as well. So we decided to handle this one state holiday using basic profit holiday regressor. We decided to add this one manually, and I'm going to say we will add this one, the promo, manually as well. Okay. And so if the store has a promo or not, and you're going to make a huge assumption. The assumption is that, I don't know, you're a store manager, you're experienced, so you have run this store for a decade, and you have a clear pattern for promotion, for promos that you want to give it, right? You know that January was like this, February is like, et cetera, right? So our assumption is that your next year promo is going to be exactly the same as previous year promo. This is an assumption. Is it valid? I don't know. But again, this is a competition. This is a Kaggle competition. You can run these things and see it's better or worse, right? So again, promo is one column you're using. School holidays, another column is using. State holidays, something we're implicitly using. But I'm playing that because I'm only looking at open days. This should not have any. All right, that's it. I'm not going to use customers because honestly, predicting customers into futures is difficult, right? You can. It can say my next year customers are pretty much the same as last year customers. But again, things like this, me personally, will not really like too much into the future because look at COVID. Prediction could not stand. Holidays could still stand, but this or school holidays could still stand. But something like this, it's not gonna work. Okay. All right. So hopefully you're getting a sense what we're doing. Again, at the high level, we're comparing the univariate benchmark to this now multivariate and see which one is performing better. Yeah. Okay. So here's how I do it. I'm going to say DF profit. So as a reminder, let me show you. Hopefully I haven't run this line yet, but we'll see. Dot head. Okay, so this is our data set that we use for benchmark, the base model. Now we're going to add some columns to that. School holiday, I simply copied from store opened. And the promo, I simply copied from store open. And this is a new data set. Does that make sense? So I have a multivariate data set now, and I need to create my feature. Again, this set is the most important. Well, not this one, next app. So right now with this is my train set. I can go ahead and train them off, right? This is what I'm doing. So with those two extra columns, I'm making a prediction, right? So this is our custom models, change point, fire scale, again, 5%. They're using a default values. So range 80%, seasonality mode, additive, seasonality prior scale 10. Again, I'm not changing anything, but we can play around with that. The reason that I don't change it, use the default values for now, because today we're going to do 100 parameter tuning, which is automatic. We're going to change these things automatically, right? All right. So then here, this is, guys, you remember I told you that I'm going to implicitly add that holiday effect. So hear me out. I'm using two terms, explicitly, implicitly. I'm adding school holiday and promo explicitly to the model. And I know that holiday might matter, so I'm adding it implicitly by doing something like this. But I know that because I'm only using open days, this thing shouldn't matter. Are we all clear? Okay, great. Do this step if we were using the open days only. Again, I am adding regressors to this model, and the regressor is a school holiday. One of them, I'm adding it additively or multiplicatively. We can do it in whatever way. Here I'm doing it additive because it's either school holiday, yes or no. If I do multiplicative, the zeros are going to wipe out my data, so I don't want to do that. Does that make sense? Depending on what variable you have, you can add them additive or multiplicative. I don't want to do multiplicative, okay? because these are 0, 1s. So if I do 0, it's going to just get rid of the 0 is going to multiply something. It's going to erase that value, right? So I'm going to do additive. Remember, guys, this is GAM model, right? General GAM sort of model, additive models, right? So if you want to have a regressor and then you want to see the effective value regressor, if you multiply 0 to some values, it's going to wipe out that effect, right? So that's why I'm going to do it additive. So their numbers are going to be 10, 10, 10, 10. When that kicks in, 11, 10, 10, 10, 11, 10, 10, 10, 11. And of course, I need to add a coefficient to that, right? So 10, 10, 10, not exactly 11, depending on the coefficient for that regressor. All right, cool. Okay, so this is the additive multiplicative thing. So I added the school holiday and promo in an additive manner, and that's it. We're going to train the model. So now this model has been trained using 3 variables: the data set itself, school holidays, and promos. So we implicitly added holidays. Okay, so before making any predictions, I need to create the feature data set, right? So I call it feature 2, not to mix it with the previous one. Feature 1 was only days. Feature 2, we start with dates column. So we say, let's go ahead and predict 365 days into the feature to make it apple-to-apple comparison to the benchmark. And now this is a challenging part, right? I need to, because my models are conflate if I simply say predict on this feature 2, right? Because it's looking for extra regressors. So I need to create those extra regressors into the feature. Is everybody follow? Okay. So let's do that. Look at the shape. Again, I think I really want to do shapes when I'm coding. It gives me a sense of what we're doing. Your train data set is something like this. 781 observations with 4 features. This is your feature data set, 1146. And again, this is the most difficult part. This is the most subjective part of your modeling when you're doing pastry profit, especially if you're doing multivariate, right? This is just, I want to visualize it and show you what we're doing, right? So again, I'm just plotting this, training this. This is a bunch of 0, 1s and forecasting lists, right? So from observation 1 to 700 something, this is my first 2 years, is train. And from that thing, 365 days is forecast. Okay, so at least this, you have a sense of this index. What is this index, right? Because I wanted to get a complete understanding of it, because we are going to use it later. Remember, I call it train index, forecast index. Okay, just remember that. All right, so now we're going to add the extra regressors to the feature 2 data frame, since we need them to make forecasts, obviously. For train set, it is easy. We just need to add the regressors to the feature 2 data frame. Is this part clear? In the train set, I'm going to just pick that 2 columns, school holidays and promo. That's simple, right? Look at that. Feature 2, location, train index. These are the index, and this is a column. And then borrow the values from DF profit, school holidays. I know that my DF profit goes from day 1 to 780 something, 2 years. Okay. Guys, this part is not fancy. The next part is fancy. This part is simply copying everything, copying the columns from train set to this thing we call feature 2, right? In sample. All right. So yeah, exact same thing. But this is the other part. This is the second part, right? So now we need to add these 2 regressors to the forecast data frame as well. We will use the last. So this is the assumption that we made. I'm going to use the last known values in the past 365 days from the store 1 data frames, and not the store 1 open data frame. So I want you to just read this and tell me why. Remember, what is the store 1 versus store 1 open? The store 1 is all open and closed. Store 1 open is all open days, right? I'm saying that I'm going to work with store 1, which has both open days and closed days, to create this feature 2 data frame. Why? When I say feature, make feature data set and forecast horizon is equal to 365, I'm creating dates for open and closed days. Right? So that's why if you want to borrow any information into the future, you have to work with, if you want to borrow 1 year of information, that year should include closed days as well. So that's why you're working with that one. So one, and remember, the source came chronologically. I've stored the index to make them chronological again. And if I compare this on so one open, we have information for this, right? January 1st, which you cannot find in so one underscore open. I'm going to use these columns, promo and school holiday. School holidays, yes, promos, no. Okay. So I'm going to use the past. Actually, if I look at the tail of it, let's do tail. Well, you get the idea. If I use the tail, I'm going to use the past 365 days of these two columns and add it to my feature too. You good? Excellent. All right. So the reason I wanted to show you head because I'm going to show you that in the data set, we are adding this thing. Okay. All right. So store one open head again. For store one, there's no January 1st. Okay. So this is what I'm going to do. I'm going to say feature. This is a feature 2 data set that we want to provide to preprocessing. The index, look at the location. Index is what we call forecast index. The 365 days from July 2015, and use a school holiday. What values you want to use from store one? The last 365 days. If you do store one underscore open, it's completely wrong. It's going to mess up the opens and close days. You good? All right. And again, guys, this is a Facebook profit thing. You cannot, if you're working with daily data, if your make future data frame is 365, it is going to create 365 days. Either it's close or not close, or it's Saturday, Sunday, business day. It's going to create every day, right? So that's why we have to be careful. And if you have, for example, if your data set by construction doesn't have values for Sundays, you have to create it manually, right? You have because otherwise you cannot create this feature data frame. I hope that you're seeing the limitation of basic profit as well. Right? It's not as clean as you think. No, sometimes, especially when it comes to handling all these. So you have to be on top of your data set and the feature of basic profit. Okay, so I'm copying school holidays. I will I feel pretty confident about this assumption that you're making. Use the past 365 days and into the future. I'm totally fine with this assumption. With promo, I'm not confident, right? Because why the last year promo should be exactly the same for the next year promo. But again, I'm making this bigger assumption. You have been running this store for a decade, you have a good sense, so probably there's a cyclicality in the promos you're offering. This is a big assumption. You see if it works or not. How do I see if it works or not? Remember, guys, you're the owner of the model. You can switch on and off any of these variables and see if it performs better or worse. So now this is my future 2. Hopefully I didn't buy multiple times. And what I wanted to show you, I want to see that January bank. There you go. This is what I was looking for. So do you see that it's there? Of course, there's no promo, but school holiday is 1 because it's a January 1. So now I know that this is what we are creating for the features data set, right? I couldn't borrow this information from open days, so that's why we borrowed it from all the data and we extrapolated 1 year into the future. Does this make sense? Okay, so it's working. So the fact that I just wanted to do some sanity check and see if it's working or not. It is working. January 1st should be school holiday, and it is school holiday. All right. Now with that, we are ready to make predictions. Remember, in order to fit the model, I didn't need any of this future data set, but we want to make forecasts into the future. We need that manipulation. Okay, I call it forecast 2. Let's do that. So these are the change points. The model decided to pick, I don't know, 4 of them, 1, 2, 3, 4, 5 of them. And again, we didn't change any of the default values yet. We're just visualizing it. And here's the part, guys. This is the part that I got so excited about it. Look at that. The trend, probably pretty much the same as before. Guys, when I said this before, I'm comparing this one with my benchmark. This was my benchmark. This is my benchmark, right? No extra variables, just univariate time series forecasting. Just take a picture of this in your memory, right? So this is trend, this is weekly, this is monthly. Now I'm doing the one with extra features. Trend is pretty much the same because we didn't change the default values. Do you see this new thing, holiday? It's flat. Does this flat thing make sense now? Why is it flat? And guys, if you read I was curious because I wanted to see what other people are doing, discussion, if you read other people's code, and they had used Facebook Profits using DE as holiday and say that you don't know why it's not picking up the holidays. You following? It should not pick. If it was picking up something, I was doing it wrong. It should not pick up anything, okay? Because this is the way that so just be aware of what you're doing. So this is a good sign because this is only modeling the open days. It should not pick up anything for holidays. And this is good. Weekly, pretty much the same as before, and annually, pretty much the same as before. This is new. Extra regressors additive. So this is a combination of your SU dates and promo. It's a combination. You cannot have it separately because you added two columns. So a combination of the two is giving you something like this. Pay attention to the magnitude, to the fluctuations and everything, right? So for example, obviously here we get all positive days. It seems that if the school is closed and if there's a promotion, we are going to get more sales for both of them collectively, which makes sense here. We good? All right. If you want to see the net effect of one of them, you have to create more models. So this is our second model. We can do this the third model, fourth model, and et cetera, et cetera. Just do them separately and see what is the isolated effect of promotion. What is the isolated effect of the other one, school base? Okay, this makes perfect sense. So interestingly, it's not negatively impacting your sales. So if the school is closed and if there's promotion, obviously you're going to get more sales. And depending on your data set, this thing can pair negative as well. The same story for holidays. The holidays are negative, positive, just like weekly, negative, positive. And the scale is not small. Look at that. My sale is at the scale of 5,000-ish on average. This is huge. This effect is huge if there's promotion or not, right? So right there, see something like this. I want you to train your brain to become a modeler. Before I haven't compared the proposal of my benchmark with this one. Which one do you think should work better? I want you to look at the decomposition and then make a guess. Is my question clear? So we have two models, univariate, multivariate. Which one is performing better? Look at the effect of your extra regressors. It's huge. So probably there was something there that your univariate time series is not picking up. So my gut feeling right there by saying this is that my multivariate models should perform better. Does it make sense? If magnitude of this was minimal, so I don't know, you had the same thing, but it goes from 0 to 50 and your average is 5,000, I would say, you know what, this regressor that you added, it's not right. They call it nothing burger. It's nothing, right? Does this make sense? Okay, cool. Okay, this is what I want you to, I don't know, train your eyes when you're working as a data scientist, right? Or things like this, right? You will be surprised how many people you're raising question why it's not picking up. Is there something wrong with holiday package in Python? Of course, nothing is wrong. You should get the flat line for holidays because you're modeling for open base. What if this was going up and down? That meant that my assumption that I can implicitly model holidays through that forecast, through that holiday package was wrong. And then I have to add it manually to the data. And by the way, this is just, if you want to see the name of the holidays for German calendar, you can extract that. M2 is what we trained on because we added that holiday. Now we can train holiday names. I don't know. If you're German here in the room, this should make sense. What is this? Essential name? with Monday, German, I don't know. Okay, anyways. So now let's get into the fun part, comparison. Your gut feeling is telling you that the multivariate should do a better job, right? So let's see if that's the case. And guys, you're using cross-validation, obviously time series cross-validation, because that's a fair way to compare these models. I could have just look at the performance in the forecasting horizon 365. That's also a possibility. It's not wrong, but a better way is to do cross-validation, especially if you're doing hyperparameter tuning, right? So I'm saying that training model used 2 years of data and rolled over every 30 days. Your forecasting horizon is 42 days. Why? Because in the competition, you were told that you want to predict 6 weeks into the future. So that's where I got this 42 days. Okay. And yeah, nowhere said that this is what I said, because I want to train a model which is good at forecasting 6 weeks into the future. Because you guys remember, if you change that forecast horizon, the model is sensitive to that, especially for something which is not well behaved, like stock. This is probably not well behaved either, right? So just remember, if you are working on a Kaggle competition, the task is forecast 6 weeks into the future, do the hyperparameter tuning, modeling, everything on that 6 weeks, because if you change that number, the entire thing is going to change. And sometimes, I don't know, then your models are going to perform differently, and et cetera, et cetera. So this is our initial training for you, horizon, and how do I want to roll it over 30 days? Why 30? Honestly, I pick it randomly. You can do whatever. But as long as you're using a fair number when you're comparing different models, this is good to go. All right. So I'm going to, you saw this thing last time. We were doing cross-validation for M2, initial, period, horizon. This is going to take errors. So this is, now I have access to this DFCV M2, cross-validation for M2. This is my custom model with additive regressors. And we know what they are, right? So we talked about this cutoff points. And this is, so for example, the prediction for 23rd of January is this. What was the cutoff? The cutoff was 20th of January. So 20th of January is cutoff, and then do how many days? 42 days from January 20th, right? All right. So then you want to look at the metrics. Remember, we saw this last time as well. Performance metrics, past this data frames that I just created. Rolling window point boundary. Remember, what was this one? 10%. We were basically saying use the 10% of your forecasting horizon. Remember, my forecasting horizon was 42 days. 10% of it is 4 days, and use moving average. So that's why you don't see numbers before 10. So here, our last example was monthly data. The numbers didn't add up. But here, because this is daily data, it must add up. I have 42 days. If I change it to 20%, so 20% of 42 days is 8 point something days. So it's going to be 8 days rounded off, right? We go from 9. Okay, there you go. All right, so we go back to this 10%. And now we can visualize that, for example, the mean absolute percentage error. So mean absolute percentage error, remember, we are doing 42 days into the future. So started from, if I use wrong, maybe 10%, started from 4 days. It's pretty, I would say this is a stable, kind of stable, because the average is pretty much 10%, mean absolute percentage error. And this is good news, right? Because this is just screaming at me that this model is kind of working. And when I increase the forecasting horizon day from 10 to 40, it is kind of stable. I have highly encouraged you to run this thing for stock price, and you will see that it will explode. As you go, for example, from forecasting 10 days to 20 days to 30 days, just go up. But that's a sign that it's absolutely not well-behaved data or not forecastable data. All right, so this was my mean absolute percentage error for this second model, which was customized. Let's repeat this exact same exercise for the first model, which was the benchmark, right? The univariate. So I'm going to call them df_cv_m1. This is my benchmark. And make sure that you're looking at the same metrics. So map here, exact same numbers to make sure that it's a fair comparison. Your gut feeling was telling you that on average, it should give you a better number. And let's see. I'm gonna put them. I'm gonna put actually the metrics in a nice data frame. This is pretty straightforward to follow. I encourage you to just, I don't know, follow the code. What I'm doing is say that from the metrics, drop the horizon column, take the average, and then basically this is the entire average of this. Look at that. So give me the average MAPE. The average MAPE, whatever it is. So it's close to 10%. Visually for Model 2 was close to 10%, right? For Model 1, it's close to 15, 18%, right? And an easier way to do that is this. We can look at the average and standard deviation at the same time. So this is for Model 1, your benchmark. This is for Model 2, your new model with extra regressors. And the variable of interest for me is MAPE. The benchmark 60% with 5.5 standard deviation, 10% to standard deviation. We have a clear winner for it, which is Model 2, which is adding extra regressors. Again, back to your butt billing thing, seeing the effect of extra regressors this large, even without running a comparison, I kind of knew that this model should perform it. Okay. All right, so now we have a winner, which is our custom model, right? Here we go. Now the last part is just, do you remember in the custom model, I use the default values? I want to play around with that. I want to do grid search, and I'm copying from the documentation. There's nothing fancy here. You have to create a dictionary and then go through different combinations and see which one is the best. That thing is pretty straightforward for any kind of machine learning type of parameter, right? So again, there are more things to play around with, but I'm gonna only play around with the shape form. This is my top, and seasonality, which is the signal. I'm not looking into the magnitude of holidays because the holidays were not there. Okay. All right. So 1, 2, 3, 4, 5 numbers for chain points. 1, 2, 3, 4 numbers for seasonality. 4 multiplied by 5, so 20 different combinations. So we are trying 20 different combinations and see which one is the best, right? So we have seen some like this in the machine learning course when you're doing hyperparameter tuning or, I don't know, a random forest model, and etc. Just as a reminder, as I increase the chain equals from 2.001 to 0.1, do I get more shake points or less shake points? Do you remember last class, if we increase that number, we get more cutoff points, right? But by default, it's 25 in the first 80% of the data. And now if I use 0.001, so I say no cutoffs, just a linear extrapolation. We kind of do a large number like 45, or I'm 10, 15. Large number to exploit all the 25 cups, go up and down. So it's obviously it's overfit. And how do we know that this thing is not overfit? Because we know that it's running cross-validation behind the scene and then report the cross-validated make. If you use this, yes, the proposal in the train set is going to increase, but in the cross-validation is going to decrease. So, okay, so this is going to take a while. So I just want to show you, this is our parameter grid dictionary, right? So there are 20 different combinations. I'm showing you the first 4 of them. Obviously, this one, and this one, this one, and this one, this one, and this one, this one, and this. So these are the first 4, and etc. Okay. And the seasonality, if I increase this magnitude, the magnitude of seasonality is going to be increased. If I use 0.001 or 0.01, it's not going to capture seasonality. It's going to do something like this. All right. So now I'm going to work with my M2 model because remember, guys, the M2 was the winner compared to M1. So I'm just reminding you that thing here. Again, these are the default values. I didn't need to run this again, but it doesn't hurt. I can do it because we already have M2. Probably I just wanted to refresh your memory. What is M2? And yeah, now this is the part that we're going to do this all in a for loop. So MAPEs are the variable of interest for me. So I'm going to create this MAPEs, and it's going to have 20 numbers in it based on 20 different combinations. I'm going to pick the minimum and then extract the parameters out of that. Are we good? Okay. So that's why I'm creating an empty list, put it in a for loop, parameters in all, remember this all param was a dictionary. It's going to go through 20 different combinations. For each of them, create a profit model with the parameters. Does this make sense? These parameters are common. This is quart, right? When you do stars is key value arguments, right? We call it quart. And then params in all params, again, this is the first set of parameters. This one, literally this one. Second, third, itself. So for each set of parameters, train a profit model, and the rest is pretty much the same. We were adding that regressor. I'm not adding holidays because we knew that holiday doesn't matter. So we knew that this thing didn't matter. So we're not going to add it here. But we are going to add a school holiday. We are going to add promo. We fit that thing. We do cross validation. And I'm not going to touch those initials, queries, and horizons. And we are going to extract performance metrics, call it in df_p, using 10% rolling windows. And the only variable of interest is mate. So I'm going to save that one and append it to my mates empty list. So this for loop, again, if you have taken machine learning with me, you have seen this many, many times. And at the end of the day, I'm going to put all the parameters in a nice tuning results and extract and add the mates as a column to that. So this is going to take maybe a couple of minutes. We'll see. On my computer, we only have 20 combinations. And here, Google Colab also is fast, So it's going through that 20 combinations and save the mate for each combination. And I'm going to visualize it and see where the minimum of mate is happening. That's going to be my winning model. So here's a question for you. Is this 100% optimized? So your hyperparameter tool is as good as your dictionary for parameters. Are we good? So is it global optimal? Absolutely not. How can you get close to global optimal? Just increase this range for parameters and try different combination if you have a fast computer and see if you can get there. So my point is that sometimes, when you do hyperparameter tuning, you think that it's the best model. It's not the fastest. So just keep that in mind. I think in the PyCaret, we talked about the caveats of the tuning part of the PyCaret, right? It is good as it can be as good as the range of your parameter dictionary, right? I think it is done. Okay, maybe only 2 minutes-ish. It's done. Then we can, yep. Yeah, all right. Now we can look at our tuning results. Again, I have 20 different combinations, right, from 0 to 19. And I have maps. And at one point, one of these maps are minimal. So I can either sort them, or I can visualize them, or I can do odd name, right? So all of the above. So here is the visualization version. So it seems that the first combination here was the best. It seems that the best parameter is 0.0001 for change point and 0.01 for seasonality. So how do you interpret this one for me? If I go back, so what is your task now? Okay, you know that you should not use the default values, because the default value here average MAPE of 10%. Here you're getting an average MAPE of 6%, which is obviously better, right? And it's telling you that trend, that 4 things that you use was overkill. That was overfit. Okay, so this part, this is overkill. So it seems that now if I change it to 0.001, so hopefully you're following, because out of the hyperparameter tuning, I know that the answer was 0.001, right? So let's do that. Well, basically nothing. And it should make sense, right? Because look at that, look at this. Hopefully it works. Yeah. There you go. You only needed one, maybe. Well, actually, no cutoffs, right? It's just, if I look at the trend component, the trend component is just up and down or something. You're good? All right, that was pretty much it.
Now we can go back to the slides and see what's the plan for next video. So yeah, we covered the Facebook Prophet, the theory, and obviously the Python application. We covered two notebooks, the basic one and advanced one. The basic one was univariate, the advanced one was multivariate. And in the next video, we will start talking about the NeuralProphet, the extension to the Prophet model, why we should move beyond Prophet, and why NeuralProphet is performing better in some setups compared to Prophet. All right, until the next one, take care. If you're looking to stay updated with the latest versions of the course's materials, please make sure to follow my GitHub and remember to refresh your repositories periodically. If you find yourself needing a bit more background in econometrics, machine learning, or deep learning, check out my other YouTube videos for additional insights. And for all the latest news and quick updates, don't forget to follow me on Twitter. Thanks for joining me, and let's keep learning together.